Hello, math magicians. Today we are finishing up 5-6 notes about similar triangles. This is our last lesson of learning things, of learning new things before our unit test. Remember that our unit test is on April 14th. And I've made these notes before I've confirmed what time during the day. I haven't even sent out the form yet. So hopefully by this time I have told you what time as well you're taking the test. If not, that's going to be coming soon. All right, we are gonna finish our warm-up for today, kind of getting us ready for the proofs. We're gonna spot whether or not these two triangles are similar. We don't have to prove it, we just have to know if they are, and if they are, we're gonna write a similarity statement and the reason, the postulate or theorem that we used to determine whether or not these two triangles were similar. Here we've got two triangles, we've got these tick marks, and these tick marks are showing us that this whole segment right here is equal to this segment right here, which is equal to this segment right here, which means that I've got 2 of that segment compared to 1 over here, and the exact same thing is happening 1 of these guys as compared to 2 of these guys, which means that no matter what that measurement is, if I set up a ratio between those 2 corresponding side lengths, they're going to be proportional. So that's 2 sides as being set as proportional. I don't know anything about GH and KL, but I do know that these angles right here are equal because of vertical angles. So this is going to be our side angle side similarity criterion in order to say that triangle. Is that an I? Yeah. Triangle IGH is similar to triangle ILK because of the side angle side criterion. Ta-da! All right, this guy's a little bit tricky. I don't know. I know that if I were to prove it, I could do vertical angles, or I could do side, side, side. So I could use vertical angles to do side angle side, or I could do side, side, side. I might be looking at this and not know exactly which side lengths to set up. So I'm going to set up my small, medium, large with each of them. I know that 5 is the smallest, 7.5 is the largest, or sorry, the medium, 10 is the largest. And then I continue with that here. So I want to see if all of those guys are similar. I'm going to put 5 on top here and then 3 on bottom, which means that the larger triangle is going to have to be on top for all of those guys. 7.5 over 4.5, and then 10 over 6. 5 divided by 3 is going to be 1.66666. Repeating, 10 over 6 is going to be 1.4, right? Oh, no. I'm thinking of something else. Yeah, so that's going to be 1.666666666. And then 7.5 divided by 4.5, if I divided both by 1.5, I would get the 1.66. Repeating again. So since all of those ratios are proportional, then I know that those two triangles are similar. So triangle FGH is similar to triangle LKH because of, I'm going to say the side, side, side similarity criterion. If you wanted to prove that vertical angles were equal here, you could have also done side angle side. We are not given that these lines are parallel. All we're given is side lengths. We do know that D is equal to itself. So comparing this triangle right here to this triangle right here, we know that they at least share that angle. So if I wanted to then prove that these two triangles were similar, I would need to prove that the sides on either side, because I don't know that those lines are parallel, so I couldn't do parallel line reasons. I would need to prove that their corresponding side lengths are equal. If I wanted to prove that their corresponding side lengths were proportional, I would not do 6/3. 6 is the whole side length for this triangle, which means that the corresponding whole side length for that triangle would be that whole length, right? So that would need to be 6/9. And then this guy would be 12/17. Already know that they're not similar. 6/9 is 0.6. Repeating 12 divided by 17 is 0.70. Doesn't matter. So they are not similar. The side lengths are not proportional. So the answer here is no conclusion or not. Similar. Okay. We are given that two angles are equal here. That's this angle and this angle. And then we're given corresponding side lengths. Just realize that for, I'll call it the yellow triangle. For the yellow triangle, this is the smaller side and this is the larger side. But for the blue triangle, 6 is now the smaller side length and 9 is now the larger side length. So I know that that one angle is equal to the other angle. So in order to then prove that those guys are similar, I would have to prove that the side lengths on either side are proportional. So the yellow triangle, the small side length would be 4 compared to the blue triangle's small side length, which is 6. And then the yellow triangle's large side length, which is 6, compared to the large triangle's large side length, which is 9. 4/6 is 2/3, and 6/9 is 2/3. So that's 0.6 repeating. They are proportional, which means that those two triangles are similar to each other. Triangle MNO is similar to triangle ONP because of the side angle side similarity criterion. Okay, so that's just a little quick warm up on being able to spot it and maybe being able to figure out a thought process that goes along with solving for these guys to be similar. We are right now given that all of those side lengths are proportional to each other. Which means right away, if all three of those corresponding side lengths are proportional to each other, it means that the triangles are similar because of the side similarity criterion. So that's what the given is leading us towards. But it's not exactly what our end goal is here. Triangle ABC is similar to triangle ARS because of the side similarity criterion. We want to then say that angle B is equal to angle R. Well, we know that by the definition of what it means to be similar, going back way up to the very beginning, the very definition of what it means to be similar is that all corresponding all corresponding angles are equal. So I can now say that angle B equals angle R. Because corresponding angles of similar triangles are equal. And we've finished. QED.